Hello, SWK 351. This is James here. We're in chapter 26. I'm sorry, chapter 16. And we're looking at the high school GPA and first college GPA scores that are given to us starting on page 269 in the textbook. So if we take a look, we have 10 GPAs, grade point averages from high school. And then we're also given data on the first year of college GPA. And so if you take a look at these grade point averages, you get a quick sense for kind of the range here. And then when we look at these college GPAs, now remember these are for the same individuals. So that may suggest a t-test. A matched pairs design. But what we're going to do today is we're going to do a linear regression on this high school GPA and college GPA data. And essentially we're kind of, just like we were in chapter 15, we're kind of thinking about well, whether or not there's a correlation between our predictor variable and our response variable. As I suggested for the in the chapter 15 video, we're going to go ahead and start with a scatter plot. And the reason here is it just kind of makes sense. It's a good visual for when we're looking at two quantitative data sets at the same time. And if we're thinking about this idea of correlation as just a natural fit. So I'm going to insert a chart for the data that I have selected. When I go to charts, I want scatter plot, and I'm just going to choose this scatter chart option. So there it is, and see if I can get this to zoom for us here. And that's the one that we want, so I'll insert it into my spreadsheet. So as we look at this data, you can think for a moment, as we're reading from right to left, does it seem like there's a pattern with the data? Do they seem to be decreasing as we go from right to left? Do they seem to be increasing as we go from right to left? Or is there really no pattern at all? And it might make sense to make the guess that as we see an increase in the high school GPA, we may expect a higher college GPA in that first semester. But we'll go ahead and run our linear regression here. Now the linear regression is going to give us the same correlation coefficient if we did the correlation, but it's also going to give us what the information we need for a line, and that's going to be our slope and our y-intercept. So what I'm going to do now, we have our data selected. I'm going to come down to linear regression. Now this is where we have to be very careful. If you look at our input for the y range, the y is our response. And as I said earlier, we want our college GPA to be the response. We're asking the question about, does the high school GPA predict the college GPA, or what would that prediction look like? So for the input range for y, that's our response variable. For our x range, that's our predictor variable, which is this high school GPA. We have the labels in our data. We don't need this 95% confidence interval. And then these are some additional plot options. I'm going to click on a couple of these, and I'm really just trying to trick the program here. I have to select an output range as well. Since I have this chart here, I'm going to come down a little bit lower for for the output. And I'll just have to scroll to see the results. So when I click OK, we will get our linear regression information. This multiple R is the same R value that we had from before. That's our correlation coefficient. We have this R squared value, which tells us about the associated variance in our predicted variable with our predictor variable with our response variable. And then when we come down here, we don't need the ANOVA for this calculation. What we need are these coefficients. This intercept is our y-intercept. And this, it says high school GPA, that's actually our slope. I could actually come in here and just override this and say slope. With regards to this coefficient, there's the additional statistics here go with this idea of that high school GPA. So, but for the purposes of this coefficient, that's the coefficient for our slope. If I come down here, we get some information on residuals, and if I scroll over, we can get this plot right here, which has our actual values for the college GPA. Those are the orange values. And the predicted GPA would be, this is from that line of best fit. These are the values, the blue values from that line of best fit. So that gives us a visual sense of how close the orange GPA data, the actual data from that we collect that we were given, matches with this line of best fit. So the thing that we have to do now is to report our results. And for our line of best fit, we have y equals, and it's actually that, it's y, they use a y bar, and that's because it's a predicted value. So this special y bar equals, well, 0.704 times x plus 0.720. That's our line of best fit. Now remember, from chapter 15 we can look at our degrees of freedom and decide whether or not our correlation coefficient of 0.68 is statistically significant or not. But for chapter 16, we're looking for this line of best fit. And this is the line of best fit that we get. And you'll note that it should agree with the line of best fit that we have on page 274 for y prime equals 0.704x plus 0. They said 719. I rounded up to 0.720. And that is how we use Excel or Google Sheets to compute a line of best fit.